December 2nd, 1984. 9:30 at night. In the Indian city of Bhopal, a worker is flushing out the inside of a pipe with a hose. A routine maintenance job. The kind done in every factory, every day. But at the end of this pipe sits a tank holding 42 tons of toxic chemical. And that tank is supposed to be protected by 3 separate safety systems. The first is shut down. The second is under maintenance. The third is out of service. Within a few hours, this water will trigger the deadliest industrial disaster in history. So how does a bucket of water poison an entire city? Let's rewind. Bhopal sits in the heart of India, a city of roughly 900,000 people. And at its center sits a pesticide plant owned by the American company Union Carbide. The plant produces a pesticide called 7. And to make it, they use one of the most dangerous chemicals on Earth as an intermediate, methyl isocyanate. Mike, for short. Mike has a nasty trait: if it touches water, it starts heating up. And the hotter it gets, the faster the reaction runs. A self-feeding loop, chemists call it a runaway reaction. You can't stop it once it starts. You can only prevent it from starting. So the rules are simple: keep Mike cold, and never let water near it. To enforce that, the plant built a 3-layer safety system. Let's meet these 3 systems one by one, because this story is really the story of these 3 systems. 1. The refrigeration unit. It kept the tank near freezing, to slow down any possible reaction. 2. The gas scrubber. If gas ever escaped the tank, it would pass it through caustic soda to neutralize it. 3. The flare tower. Anything that got past the scrubber would be burned off at the stack. On paper, flawless. 3 separate walls. Breaching one isn't enough, disaster requires all 3 to fail at once. So how low could that probability really be? Here's how: in the early 1980s, pesticide sales are falling. The plant is losing money. And headquarters wants cost cuts. Staff is cut in half. Training is shortened. Maintenance is delayed. And then it's the safety system's turn. The refrigeration unit shut down months earlier because the electricity bill was too high. Its coolant was even stripped out and reused elsewhere in the plant. The tank isn't cold anymore, it's sitting at ambient temperature. The gas scrubber put on standby because there's no need, production's down. The flare tower under maintenance because its pipes had corroded. The connecting line is sitting disconnected. 3 walls. All 3 down, on the same night. Would you have noticed if you worked at that plant? Probably not. Because nothing was happening. These systems had been off for months, and nothing had gone wrong. When danger becomes invisible, it's easy to act like it isn't there. Until the night of December 2nd. 9:30 p.m. The night shift is given a routine task: flush out the pipes leading to the Mike tank with water. Normally, there's a rule for this. Before flushing, a metal disc called a slip blind is inserted into the line, a few dollar plate that makes it physically impossible for water to reach the tank. That night, the plate isn't installed. Why? Because installing it was maintenance's job. And that position had been eliminated in the cost cuts. The task still exists on paper. Nobody's left to do it. That's not even the real mistake, by the way. We'll get to that. Water flows into the pipes. The valves inside haven't been serviced in years, and they're leaking. Drop by drop, water starts entering tank E610. About 1 ton of water meets 42 tons of Mike. The reaction begins. Slow. Silent. The tank starts heating up, but remember, the refrigeration is off. There's nothing left to slow it down. 11 p.m. An operator in the control room notices the tank pressure climbing. A bit above normal. But he's not worried. You wouldn't have been either. Because in this plant, gauges are constantly malfunctioning. The pressure sensors have been giving false readings for years. The gauge is broken again, is a far more reasonable explanation than the tank is about to fail. That's the invisible trap. Once you get used to ignoring a system, you also stop hearing the alarms it's trying to give you. 11:30 p.m. Workers on site start feeling their eyes burn. The classic first sign of an mic leak. They assume it's a small leak. Small leaks are routine here. They decide to look into it after their tea break. December 3rd, 12:15 a.m. The gauges in the control room leave no room for doubt anymore.
I can't reach the
Tank
override.
temperature is off the scale. Pressure is many times over the design limit. 42 tons of mic are boiling inside. The operator tries to route it through the scrubber. It doesn't work, it's on standby. He tries the flare tower. Impossible, its pipe is disconnected. In that moment, three separate cost-cutting decisions made months apart converge, in the same control room, in the same minute. Around 12:30 a.m., the tank's safety valve, unable to withstand the pressure any longer, blows open. Roughly 40 tons of toxic gas begin pouring out of the stack into the night. Mic is heavier than air. It doesn't rise, it sinks and spreads along the ground. And that night, the wind carries the clouds straight over the city's most densely populated, poorest neighborhoods. Hundreds of thousands of people are asleep. Sirens. The plant's public alarm system had already been silenced, because false alarms were causing panic. The city wakes up not knowing what has just hit it. No one knows exactly how many died that night. The official initial count was around 3,800. But in the years that followed, counting those who died from the gas's lasting effects, estimates range from 15,000 to 20,000. Over 500,000 people were exposed. In Bhopal, people are still living with the health consequences of that night today. And now, the hardest question, what could have stopped this? A metal plate worth a few dollars. If the slip blind had been installed, the water could never have entered the tank. But careful, if you walk away from this thinking one worker forgot a plate, you're missing the point. Because that plate wasn't even the last line of defense on its own. If the refrigeration had been running, the reaction would have been slower, buying hours for intervention. If the scrubber had been active, most of the gas would have been neutralized. If the flare tower had been standing, what remained would have been burned off. Disasters don't happen because of one mistake. They happen because of a pile of decisions where everyone assumed nothing will go wrong. Nothing new broke in Bhopal that night. Everything that was broken had been broken for months. That night was simply the first time all of them were needed at once. The world changed after Bhopal. In the US, new laws made it mandatory to inform the public about hazardous chemicals nearby. The chemical industry rewrote global safety standards. If you have the right today to know what's being made inside a factory near you, that right was paid for in Bhopal. 3 safety systems existed. All 3 were off. And on the day each one was shut down, not one of them looked dangerous to anyone.